Hi, my name is Utpal Anurag and this is video of experiment 7. So in this video, we are going to test each IC that we required in experiment 8. So the first IC is 74LS85 and which is our comparator, and the second IC is 74LS83 which is our adder. So the third component that we are going to test is 7-segment display. So this is IC 74LS85. So pin 16 is VCC, so I have connected it through the red wire, and pin 8 is the ground. Now the pin input, pin from 2 to pin 4 are input pins. So pin 2 is going to ground, pin 3 is going to VCC, and pin 4 is going to the ground. So this IC basically compares the input A and B, which are from A3 to A0 and A3 to B0, and display the output at pin 5, pin 6 and pin 7. I have tied this P2 1001, which is equal to 9. So B3 is tied to 1 and B0 is also tied to 1. B0 is tied to 1 and B1 is tied to 0 and B2 is tied to 0. So 1, 0, 0, 1. So our B is equal to 9. Now what we do is simply go and give the input to the A. So first we are going to give input equal to 2. So for that we have to connect A3 to 0, A2 to 0, A1 to 1 and A0 to 0. So now I have given input through A also. So A3 is 0, A2 is 0, A1 is 1 and A0 is equal to 0. So A and B. So A is equal to 2 and B is equal to 9. So this is representing that A is less than B. So what we simply do, we go to pin 5, pin 6 and pin 7 and measure the voltage there. And alternate we can also do is to test the output via LEDs. Now I am powering this circuit. So the LED present at pin 7 is glowing, representing that A is less than B, because our A was 2 and B was 9. So now we change our input of the A. So we simply put the A3 to the 5 volt. So now A3 goes to 5 volt. So value of A become 1010, which is equal to 10. And the 10 is greater than the 9 because our B was coded to the 9. And we can see that the LED present at pin 5 is glowing, representing that A is greater than B. Again, we change our input of the A. What I have done is, I have given the input of A as 1001, in which the A3 is connected to 1, A2 is connected to 0, A1 is connected to 0, A0 is connected to, again, to the 1. So we can see that the LED at pin 6 is glowing, representing that A is equal to B. We are going to test the IC 74LS83, which is our binary adder, 4-bit binary adder you can say. So pin 5 is connected to VCC, pin 12 is connected to ground, and this IC receives 2 input from A1 to A4 and B1 to B4 and adds both the input A and B and display the output at summation 4, summation 3, summation 2 and summation 1. So there are 2 pins, which is one is carry in and one is carry out. So carry in is tied to ground. So before we proceed, what I have done is, I have tied the input A to 6, which is 0, 1, 1, 0. So A4. So A4 is tied to 0. A3 is tied to 1. A2 is tied to 1. And A1 is tied to 0. And now we are going to give input to the B. So before that, I have taken these LEDs for summation 1, summation 2, summation 3, summation 4, and this one for carry out. So the first input we are going to give to B is 1, which is equal to 0, 0, 0, 1. So B4 is connected to 0, B3 connected to 0, B2 connected to 0, and B1 should be connected to the 1. So now we go ahead and give the input. Now we give power to the circuit. So now ground and VCC. So I have typed A2 0 1 1 0 and given the input bit equal to 0 0 0 1. So output should be 0 1 1 1. So 0 followed by 3 ones. So we can see that summation 1 is going to 1, summation 2 also going to 1, summation 3 going to 1, and summation 4 is going to 0. So now again I have changed the output of B equal to 1 0 0 0, which is equal to 8. And our A was equal to 6. So 8 plus 6 equal to 14. That will be 1 1 1 and 0. So summation 4 is going to 1, summation 3 is going to 1, summation 2 is going to 1, and summation 1 is going to 0. So now we give input of B equal to 15 and see what this is showing. So for that, we connect all the B1, B2, B3 and B4 to 1. Our input A was 0 1 1 0 and input B is now 1 1 1 and 1. So if we add this, what we got is we get summation 1 equal to 1, yes, summation 2 equal to 0, yes, and summation 3 equal to 1, summation 4 equal to 0, and the carry out will be equal to 1. So now we have tested both the ICs. We go ahead and test the 7-segment display that it is working or not. We are going to test our 7-segment driver. So for that, we have made the connection like pin 16 is going to VCC, pin 8 is going to ground. Output pins like A, B, C, D, E, F are connected to the 7-segment driver. So A of this 74LS83 is going to A of this 7-segment display via the 220 ohm resistor. So for testing that 7-segment driver is working right or not, simply we go to pin 3, which is our lamp test. We insert the tip and connect it to the ground. So it is going as a 8, representing that our 7-segment display is working right. We have tested all the components and we can now proceed to make the counter circuit, which counts from 0 to 15.